Okay.
Okay, cool. All right, guys. Well, thanks for joining us today. This is our April meeting of the Polymesh Technical Steering Committee. We've got a fairly full agenda today. So I'll try and go through things quickly, and hopefully we'll have some time at the end for some Q&A. So if anyone has any questions, you can either save them to the end or just type them into the chat as we're going along. And if somebody is able to respond to you during the meeting, they'll post a message. Otherwise, we'll get to them at the end and we can go into things in any more detail as people um, come along. So I'll introduce myself first of all. I'm Francis O'Brien. I'm the head of developer relations at Polymesh, and I mainly make sure that people have the tools, the documentations, the answer to their questions when they're integrating with the chain. And I'm also just going to chair this meeting today, just so that we can give you an update about some of the exciting stuff that we've been working on over the last while, particularly around our upcoming V8 release, which brings a lot of nice features to the ecosystem. So just quickly running through the agenda, we'll welcome and introductions, kind of what we're doing now. We'll go through the status of the Polymesh V8 release, update on the audit, how that went. We'll talk about some of the key features of the platform evolution, kind of what we've baked into V8, and try and talk a little bit about why we've done that. I'll briefly touch on confidential assets. No significant update, but I just want to kind of talk about it. We'll be presenting a bit more information about that in the weeks and months to come. Updates to tooling, just to kind of tie in with the V8, just give you an idea of what's happening with them, what the status of the different tools are, and give you an overview of the timeline for different chains, staging, testnet, mainnet, and making sure that validators and people are aware of any updates and changes that they need to make to their node configurations associated with that. Then Tugay is going to give us a demo, an EVM demo. So one of the nice features of Polymesh V8 is that it brings some EVM compatibility. It brings the Polka VM through the Revive palette, which supports Solidity. So smart contracts. So we're going to give a demo of that, and Tugay is he's providing a proof of concept bridge as part of that demo. So using a third party's bridge contracts, he's going to again demo how that will work in the EVM compatibility with the Polymesh side of things. Then just any other business, and as I said, time permitting, we'll have some technical Q&A. But again, any questions, just post them in the chat as we're going along and we'll try and address them. So the current status of V8, so the audit was complete by Hashlock. So we've got all audit findings have been addressed, closed out. We are holding off publishing the report this time until the V8 is live on mainnet. No major bugs found, but there are some that are still potentially live on V7 that we haven't felt were urgent enough to patch. So we will make them known when we release to mainnet V8. So we have already released the V8 binary. So if you go into the Polymesh repository, you'll be able to download the V8 binaries, or we also have them published on our Docker Hub repository, so you can find them at those links there shown on the screen. If you just search for the latest 8.0.0, you'll get images, Docker images for staging, testnet, mainnet, etc. Or if you search for latest, because there's a lot of images get published there on a regular basis, so you can search and find the latest. Some of them would be from developed branches, but just if you're ever looking for images, you'll find them there. So in terms of upgrade readiness, those images are available. So our node operators, RPC nodes can be updated. We've already updated all our nodes to 8.0, So we need to start spreading that word now to those in the community running nodes, so they can start bumping their nodes binaries also. So the nodes can be updated ahead of schedule, so you don't need to wait until the actual on-chain update. And in fact, we recommend that nodes are updated ahead of schedule to make sure that they're on the latest and greatest firmware. So going into a little bit more detail on what's been in V8. So without a doubt, this is the largest protocol update that we've delivered to date, mainly because the mammoth task that it was in getting us up to date with the latest Polk.SDK version. So we're moving up, I think, at least 2 years, maybe 2.5 years in terms of our um, support for the substrate framework. So substrate's been renamed as the Polka.SDK. So we're moving to stable 2603-2, which I think is pretty much the latest version that's been released, Robert, so you can confirm.
Yeah, the number is the 2026, March of 2026, so 03 is March. So it's the March stable release.
Yeah. So in the past years, as we've been doing chain upgrades, we haven't been as focused on doing a full framework modernization. We have been cherry picking in features, bug fixes and stuff. So we have been maintaining that, but this is a more a fuller update to the runtime in terms of the substrate updates, bringing in a lot of the changes that the party have been working on over the last number of years. One of the nice things that is coming along with this is the EVM compatibility that we're bringing. This is through the Revive palette. I'll talk a little bit more about that in a bit more detail. And then when Sergey is giving his demo of EVM compatibility, we'll go through, he can talk a little bit more about that and how it works and what that experience is going to be like. Some of the other things that we've kind of put in as we've been doing this update. So we've simplified DID assignments. So your DID on chain is your on-chain representation of your identity. That's where historically your assets and portfolios and claims have all been associated. Previously, that was done through a CDD provider, a certified due diligence provider, through a KYC process. We've found that there's a lot of friction with different platforms where there's a double burden on doing KYC to get a DID and then a KYC to do the asset, to be able to actually hold the asset. And the onboarding that was done to get the DIDs on our side is not sufficient for most asset issuers for any asset issuers really, for regulated entities. So it was causing increased friction. So as part of the V8 upgrade, we have made it so you can now self-assign a DID. So you can't assign DIDs to third parties unless you're still a DID registrar. So we have replaced CDD providers with DID registrars. A DID registrar can register a DID on behalf of other people, and that is still a permissioned role. Whereas if I was to come with a new key and I wanted a DID, I can self-assign that. You will not necessarily be able to hold assets on that DID that you are not, you do not have the required claims. So you would still probably have to onboard with a platform with that to go through their KYC process to get appropriate claims to meet the compliance rules configured for those assets. So we've also done made some improvements around asset transfers, simplifying them to allow single leg transfers, and also to simplify the receiver affirmation process. I'll talk a little bit more about that as well later. So one of the things we've done as part of this major upgrade is we've tried to align closer with Substrate in their standard palettes. So things like we had our own version of the balance palette, which is the kind of the basic palette that's used for transferring POLYX. And the main reason we had our own version of that was because of the DID restrictions that we would have had in the past around POLYX transfers. We lifted those restrictions in V7. So as part of V8, it's allowed us to go back to a closer version of that palette with minimal customization. We still have extended that by keeping the transfer with memo functionality that we would have had previously. So the memo functionality was primarily used because mainly exchanges didn't want to be creating DIDs for every user that wanted to deposit POLYX. So they had one or two deposit addresses, and they would use memos to uniquely identify users. With the update, we are now moved closer to the standard balance palette, which allows standard wallet patterns that are used in the Substrate ecosystem, the Polkadot world, when interacting with Polymesh. So it gives us that bit more compatibility with standard tooling and services that are out there, and just minimizes the effort for third parties in working with Polymesh versus other substrate-based chains. And then we've built in confidential assets. So this is going to be the foundational work that we've done around our confidential assets. I'll talk a little bit more about that as well. So on the EVM, so everybody and their mother has been asking for EVM compatibility for years. We've focused mainly on the Polymesh functionality, but with the work that Parity have done on adding EVM support to Polkadot, we are able to leverage that by integrating the Revive palette. So the Revive palette is the Solidity is Parity's EVM. Well, it supports their Polka VM, which supports Solidity smart contracts. So this is hopefully a game changer in terms of making the chain more familiar to developers in terms of working with. So it allows them to deploy contracts that they have already worked with on other EVM chains on Polymesh and get that functionality. It allows for bridges and other standard tooling that is common in the EVM world to work seamlessly with Polymesh. So we add support for EVM compatible transaction handling, Ethereum wallet compatibility, so you can use the likes of MetaMask to sign transactions and submit them on Polymesh through the EVM. So, as I mentioned, sorry, this was on duplicate on this slide. I forgot to take it out. It's on the next one as well, the onboarding. So onboarding, self-assignment of DIDs, as I mentioned. So the DID existence checks are replacing the previous CDD claims checks. So it simplifies some of the on-chain logic around every time we were doing transactions, we were looking up these CDD claims, making sure they were still valid. Now, the fact that you have an identity is all that needs to be checked on chain, simplifies some of the computation that's required, chain lookups, etc., when you're doing any transaction, which will all help with transaction throughput in the long run. So it reduces integration complexity. There's less burden on users to go through a KYC flow to get a DID, just to do basic operations that they want to be able to do. So now once they have POLYX, they can submit the transaction themselves to self-assign a DID, and when they want to use assets, they have that. So it makes things a lot easier for people to work with in the ecosystem. In terms of what we've done to improve asset transfers, so there are probably 3 or 4 key things that we've focused on here. So in version 7.4, we introduced account-based asset balances. So your key address, you can transfer tokens to that now. That helps simplify the mental model for a lot of people coming from the Ethereum world or from the majority of blockchains, where balances are associated with the key versus on Polymesh, where they've historically only been associated with portfolios associated with the DID. So we did have some functionality added in 7.4 for transferring assets. We've extended that in 8.0. We've introduced this transfer funds method, which is, again, it's a simplified version of the settlement. It does a single leg transfer. It will transfer from accounts or portfolios to accounts or portfolios. So it's a little bit more flexible than what was introduced in the 7.4, and it supports fungible and non-fungible assets. The nice thing about this is it will one-shot a transfer that if the receiver has already affirmed that or has pre-approved affirming that, it will execute straight away. Whereas historically, the default for the settlement engine was using the scheduler, where it would, once you have everything affirmed, it would schedule it for the next block and would execute that. So there's a lot more transparency when the transaction executes as to the status of it. That did it fail because of compliance checks? Did it execute? You'll get instantaneous feedback. We've also kind of, to link in with what we've been doing on the EVM compatibility side, added in a spender approver flow. So this is similar to what people are familiar with on the EVM side for ERC20 tokens. We've had custody and other things that somewhat were our version of the spender approver flow, but this is designed to be much more similar to the ERC20 compatibility, where if you're doing an asset transfer using the transfer funds method, you can approve another key to spend that on your behalf. So that other key could be a smart contract, as is commonly done in the EVM world, or another user. So it allows another way to just spend those tokens to work in a more similar design pattern to what people are familiar with in the EVM with Solidity smart contracts. To also improve and reduce one of the friction points that people have has been highlighted to us when we've been working with custodians and wallet providers. They're not used to having to affirm things coming in, while institutions think it's a great thing to have receiver affirmations. A lot of these people just want the tokens to arrive in the wallet when they send. They don't want to have to do another additional action to actually claim those tokens and receive them in. So mandatory receiver affirmations was the default up until V8. With V8, that is being disabled globally. So all token affirmations or all tokens will be automatically affirmed by receivers. That is something you can opt out of. So you can disable that so that you will require receiver affirmations, or you can enable it only for specific assets like you currently have, or specific portfolios like you currently have. So it extended from, the default was everyone had to affirm everything unless you had an exception. Now it's nobody has to affirm anything unless you have an exception is the default. So that reduces a bit of user friction as well in that sense. Moving on a bit to confidential assets, just to kind of update people and remind people what is happening with that. So DART is the confidential asset white paper that we have developed and written, and we are implementing that in the Polymesh confidential assets palette for V8. However, it will only be available on staging and testnet initially, or in the development images. While we don't plan to have it released on mainnet for V8, it will come at a later date once we've gone through more detailed auditing. We want to get some feedback though as early as possible on this, so we want to put it more out into the public. And just to highlight again some of the key features that make DART uniquely of interest to people out there. So it's our zero knowledge based protocol for confidential assets. So it provides full anonymity, confidentiality. So the balances are hidden, the parties of the transfers are hidden, and the amounts are the asset type is hidden also. It's an account-based system. So zero knowledge is often associated with Coinbase systems where you have multiple fragmented balances hidden across that. With the account-based system, it tries to consolidate that into a single account to make it a little bit easier for bookkeeping, which is what people are more familiar with in the traditional financial market. We include an auditability layer, so each asset issuer can assign auditors that can decrypt involved in that. We support receiver affirmations, and reversibility. Reversibility is very important in zero knowledge because if you transfer an asset and nobody claims it, you don't want those assets to be permanently locked. So if a settlement is rejected by a mediator or a transfer agent, you want to be able to reclaim those. So we have reversibility. Non-interactive. So you don't need everybody to be online at the same time to be able to settle this. So we support multiple parties in transactions where the sender, receiver, mediators, etc., do not all need to be online at the same time. Each can affirm their individual part of that instruction, and they can execute atomically following that. So it's quite good, whereas in some other protocols, you require both parties or multiple parties submit proofs at the same time and all submitted at one go. So this way it allows for better management of things. So we also support concurrency. So one instruction is not blocking the other one. When you affirm an instruction, that amount that you affirmed in that asset is locked. So you can't do double spending, but you can have multiple concurrent transactions at the same time. So these are a lot of the challenges that Dart aims to address in terms of zero knowledge confidential asset transactions. So it's very unique in this sense. So we are going to be putting out a bit more information on this. Amirez is not here today. He other commitments. He's been doing up some videos. So he started a video series, which we're going to be publishing in the coming weeks, where he's going to talk through Dart in a bit more detail. What are the benefits? What makes it unique? And what are some of the challenges that we faced and all that. Just an update on some of the tooling. So tooling feeds into when we can actually get the chains upgraded, because a lot of people who are using the chain are dependent on some of the tooling that we have in their applications. So while we have the runtime ready and it's been going through testing and auditing and all that, in parallel to that, we are updating tooling. So the Polymesh SDK, we have a dual compatibility release coming very soon. Hopefully next week we'll have that finalized. We're just going through the last updates at the moment and testing. That's being implemented into the Polymesh portal also, so that the Polymesh portal, the UI that people are familiar with for basic interaction with the blockchain and staking activities, it will also, it's built on the Polymesh SDK. So it's been the kind of the first application to test out all these new updates to us and ensure the dual compatibility functionality works. So our chain indexer is built on subquery. That's been also updated. We have an alpha release available currently, which we have tested syncing against the staging and testnet and mainnet. All seems to be working fine there at the moment. So we plan to probably release that to a full release within the next week or so. The Polymesh types repo has been updated. If you're using something like the Polkadot API directly and you want Polymesh specific types, you can use that in. So if you want, if the TypeScript types, so if you want to have IntelliSense working properly and autocomplete and things like that in your IDE, you can use those Polymesh types. The Polymesh wallet has been updated already. So I think it's version 2.6.0 was published last week. It's been pushed out in the Chrome store. It's available. It already has the updates required for version 8. We have a Ledger application that has been that is ready to go. That will be published in parallel with the mainnet update, but the wallet updates that we have made and the protocol updates that we are making actually makes Polymesh compatible with the Ledger, with the Polkadot generic Ledger app. So you can either use the migration app that is already published that they have, or the Polkadot specific app with Polymesh using that, and the Polymesh wallet will support that. There'll be a setting that you just need to toggle to change the one when you're between one or the other type. The Polymesh REST API is built on the Polymesh SDK, so that will follow closely after the SDK updates. So we'll bump the SDK version in the REST API and we'll publish an image of that. And then we also have, if people are familiar with, there's a development environment. It's a Docker Compose file that spins up a Polymesh node, instance of subquery, chain indexer, and a few other additional kind of tools. So we will, once the tooling is all available, we'll also be bumping that, just to have it so that when people run that, basically in a single Docker command, they can have everything they need for local development up and running. So there's a bit of work left to do in them. We do hope to have things ready in the next kind of 1 to 2 weeks on them, which would align with what we hope when we hope to get testnet update. So staging has already been updated, as I mentioned, so that is ready to go. Anyone can use that at the moment, but as I said, some of the tooling is not quite ready yet, which is why we haven't proceeded with testnet or mainnet updates. So testnet, I expect in the next 1 to 2 weeks, hopefully, which the main reason it's been held off is we don't want to just update testnet without giving people a chance to update their integrations to the latest versions of the SDK and things like that. While it's only testnet, a lot of people use these for demos, and we don't want to inconvenience them by breaking an application, because it's not a good look to end up breaking something in front of a client in a live demonstration. Mainnet at this point, because again, we need to give enough time for people to update their mainnet applications, is now looking to be around the end of June, maybe early July, in terms of a timeline. Just a little note on some of the changes. So if you are running a node, whether it's a validator node or an RPC node, there are some changes. So with the upgrade to 8.0, the RPC interfaces, the HTTP and WebSocket interfaces have been unified. So previously you had a WebSocket flag and an RPC flag, and there was different ports for the two RPC connections. Now they've been unified, so you'll find that where you would have had WebSocket flags previously, you'll just stick with the single RPC. So you'll remove ports or update ports as appropriate. And we've deprecated the operator flag, which was a Polymesh specific flag, which was an alias basically for the validator flag. So that just needs to be replaced. Additionally, for validator nodes, production nodes will no longer automatically generate node keys. You either have to set an unsafe flag to allow them to auto-generate or generate them externally and inject them. That is intended to make sure that people, when they generate their node keys, the fact that it was happening automatically previously in the past, people weren't really backing them up, weren't really saving them. So it's to encourage people to consciously generate those keys so that they store them appropriately. And at that, Tugay, hopefully I've left you enough time to give your demo, and I'll hand over if that's okay.
Yeah, sure. Hello, guys. My name is Tugay. Do you hear me, guys? I think I got some flash here. Yeah, my name is Tugay. I'm a software developer working with the Polymesh team for the past few months. And I wanted to share a few things related to the EVM support that we are introducing in V8. First of all, I think this is big news for Polymesh. EVM is the virtual machine of Ethereum. This is the oldest ecosystem with the largest user base and developer base. So this would allow, from user perspective, this would allow users to interact with our network using tools that they are already familiar with, probably the main example being MetaMask wallet. And developers on the other end, it will make it much easier for developer teams that are already developing for EVM to build on our network. So I will share my screen, and I wanted to make a quick demo of 3 POCs we've been working on to just showcase some of the possibilities that will come with the EVM. So sharing my screen now. Okay, do you see my screen now?
Yep.
Okay, so what we have here is a locally deployed Hyperlane bridge. Hyperlane is an open source EVM bridge. It's quite popular, supports a lot of networks. It's super battle tested. Feel free to check their site for more information. What we have here is two networks already deployed locally. One is a Polymesh network with V8, and the other one is a pretty standard EVM network. We have the TT token, which is the test token. This is a pretty standard ERC20 Solidity contract that is deployed on the Polymesh network. And the way the bridging works for specific tokens is, let's say you want to be able to bridge this token to the other network. So then you need to create this hyperlink route, which what does behind the scenes is it also creates a synthetic contract on the destination chain, which is Anvil. A little bit more about the hyperlink. So these are pretty standard Solidity contracts that are, one of the questions in the chat was actually if Solidity contracts will be able to be deployed directly or they will require modifications. So for most contracts, there shouldn't be any modifications required. For example, hyperlink worked out of the box, no modifications needed. Probably there would be some exceptions, I guess, but the big picture is that everything should work natively. Oh, yeah, besides the contracts that are deployed on both of the networks, we have hyperlink validators also running on both networks, and the relayer, which is also a required service for the bridge to work. We already have connected our MetaMask wallet. We have some balances on both networks because I have tested this previously as well. But let's try to just bridge a single token from our Polymesh networks to the Anvil network here and see the flow. Okay, so first we just see the transaction that is gonna be executed. Now I don't know if you see my MetaMask wallet as well, but pretty much a transaction appeared here to be signed by me. Let me just move this one here.
Yeah, we can see the MetaMask.
Okay, it's taken a while to load actually. Yeah, so we see a pretty ordinary transaction. You can specify fees and so on, just a normal EVM behavior here. And we're gonna confirm that. I guess my PC is a little bit slow because I'm running a lot of things, but yeah, we are trying to confirm here.
And being in the meeting.
Yeah. So what we are doing here, actually, first we are signing a transaction, which is approval. So we allow the bridge contracts to spend tokens on our behalf. And once it's done, we will proceed with spending the money.
Okay, just to clarify, this transaction that you're submitting at this point in time, that's on the Polymesh side, on the chain that you're doing.
Yeah, right. Pretty much all the transactions that you're signing are on the source chain, and the token is getting delivered on the destination chain automatically, pretty much. Still loading. Let's see. I'll just give it a few more seconds here before I try to do it again. Okay, it's loading now. So as I said, the first transaction was approval, and now we should get another one to sign. Again, being asked. And yeah, the second one is just the transfer transaction. We are going to sign that. And now what is going to happen is validator is going to pick up the transactions, they will validate them, and then the relayer will do its magic. So in a few seconds, we should have our tokens on the destination chain. I'm not sure if you remember the balances before we submitted the transaction, but let's see if things will move.
I think the receiver had 4 tokens.
As you saw there, the estimation is around 20 seconds, so the bridge is quite fast. And now we see it's all finalized. Here we can see some transaction hashes, of course, that later we will also see on the Explorer. But yeah, Minimizing that. And yeah, pretty much our balance should have moved. I don't remember what they were
It
before.
was 4 before.
Yeah, the bridge is definitely working. And of course, we can do the same the opposite way. I'm not sure if we want to demo that because my MetaMask is too slow, but you can transfer tokens on the destination chains and back. We also plan to support bridging of our existing tokens on Polymesh. We are planning to implement the ERC20 interface for that to be possible. Actually, one of the features, the spender approval extrinsic that we introduced in V8 is part of the work that needs to be done. So that's also going to be possible. And of course, the bridge will work with between any EVM chains, which is great because there's a lot of EVM chains. A lot of them are popular. So yeah, this will enable a lot of possibilities. So I think that's the main things about the bridge. And then we have another demo here. This one, yeah, don't mind, please. The interface is just, I made it real quick. The goal here is to prove that we are able to sign and send substrate messages, like substrate transactions from existing palettes on the Polymesh, using, again, native EVM tools like MetaMask. I guess the big picture here is that this will allow the apps like the portal to also support MetaMask wallets. I guess that will be really convenient for a lot of users that are just used to MetaMask. They trust it because it's proven, battle tested. So let's see how this will work. And we already have connected our MetaMask here. And the example is showing a pretty simple remark message. But of course, this could be quite generic. What it does is we are generating a transaction using a Pocket.js API. And yeah, then we turned it into EIP 1559 message, which is EVM, like EVM standard messages. And we sign it and broadcast it from there. So yeah, helpful MetaMask. Yeah, let's just try to see if that's going to work. Again, pretty normal information here. This is a standard transaction contract. It's pretty much a contract interaction or something like that. We'll confirm the message. We'll see probably some logs here, but also in the Explorer, which I'll show next, we'll be able to see all of these transactions. Everything seems to work. And the last thing I wanted to show is the Block Scout Explorer. This is open source Explorer, very popular EVM Explorer. Again, it works out of the box for network, which proves that the integration is pretty stable. And we can see that we have 3 new transactions since the last time I opened the Explorer. Let's quickly see. Again, this is, yeah, we didn't make a bridge from Anvil to Polymesh. So here you can see the first transaction was the approval. The second one, again, in the bridge was the actual token transfer. And the third transaction is the substrate message that we were able to sign and send via the MetaMask. Again, I think that's great news for Polymesh. Looking forward to see how it will work out. That's all for me. I'm back to you, Ran.
Thanks very much, today. And
yeah, of course, by the way, if you have any questions, feel free. Sorry, I forgot that. Otherwise,
yeah, well, I know it's hard to kind of convey what's going on. There's a lot going on behind the scenes with all these demos that you're doing. So you have a UI, and it makes it quite hard to comprehend all the work that's involved behind the scenes in making these things work. But the fact that we were able to use standard tooling to do this with Polymesh, it indicates that the EVM will work very similar to what people are used to doing. So it's not to be underestimated. Obviously, there would be events emitted on the Polymesh side of things as well to correspond with the Ethereum side of things. So we've shown you more focused on the Ethereum side of things here today, but we plan to be able to expand to support all the functionality of the chain through Ethereum transactions in the future, so that native assets, etc., can all be operated from an EVM wallet and through smart contracts.
Yeah, and we used this one, like Hyperlane, as the demo, because it's open source, so all of the relayers and the server side software to support it, we could run it locally. But we have looked into other bridging software like Layer 0, and so being able to take an existing Solidity contract like this and being able to just deploy it and have things work shows that that the even compatibility part is working the way it should be.
So at that, we've finished up with a bit of time today, thankfully. Well, we've finished up the core presentation. Happy to answer any questions, or I don't know, Robert, do you have anything else that you'd want to add, or Martin, that you'd like to add just before we move on to Q&A?
Nothing from my side.
Nothing from your side. Good. Okay, well, at that, I'll open the floor for any questions. If anyone wants to ask us anything about the technical roadmap, what we've discussed today, anything in general from the technical side of things, we'll try and do our best to answer that for you now. Don't be shy. Okay, well, look, if there's no questions, we can wrap it up there, and we'll hopefully talk to you again in around another month's time. Hopefully we'll have more news around the V8 for mainnet release, and be able to give you some more updates on what's been happening with confidential assets and where we are with them. So again, thanks very much for your attendance today, or if you're watching this after the fact, thanks for watching.
Thank you, guys.
Stop the recording.